Thomas Verbraken studied civil engineering at the KU Leuven and graduated cum laude in June 2007. After his studies, he worked as a researcher at the traffic engineering department of the KU Leuven and at MSCI Inc., a leading provider of investment decision support tools. He also enrolled in the CFA, Chartered Financial Analyst program, and passed the level 3 exam in June 2011. In February 2010, Thomas returned to his alma mater to start as a PhD student at the Faculty of Economics and Business, Department of Decision Sciences and Information Management. At this moment, his main research is focusing on business-oriented data analytics, which led to a profit-based classification performance measure. The main application domains Thomas is working on are churn prediction in the mobile phone sector and credit scoring in the financial services industry. In his video session, Thomas will talk about profit-driven data analytics.
Hello, I'm going to tell you a bit more today about profit-driven data analytics, and more specifically about classification performance measurement and how we can do this more profit-driven. Here you can see the outline of my presentation. First, I will talk a bit about why we want profit-driven data analytics. After that, I will briefly explain how classification models work and also how we measure the performance of classification models, because that's very important. We will then proceed to two new profit measures, two new performance measures, the maximum profit and the expected maximum profit. Those will be demonstrated in a case study in the context of customer churn, and finally I will wrap up with the key findings. Okay, so let's start with discussing why we need profit-oriented data analytics. Well, in the literature it has been described that decision makers who have access to high-quality decision support systems objectively make better decisions. So we want to promote the use of decision support systems in the industry. But we also see that decision makers or managers are not always willing to use those decision support systems because of a variety of reasons. And therefore, we need to increase the acceptance and the adoption of DSS. And we can do that in two ways. First of all, we can align the decision support systems with what managers need, with what they expect from those systems. That's very important. And secondly, we can provide the managers with some feedback on the market outcome of the several decision options. So basically what we need to do, we need to make sure that those decision support systems speak the same language as the managers, and that we clearly demonstrate how and why they would add value to the decision-making process. And we will focus on one type of analytics, on predictive analytics, where we try to predict a certain target variable. Now, a predictive analytics solution consists of two main components. First of all, there are the statistical or empirical models which are actually doing the predictions. And secondly, there are the performance assessment methods, which are very important to measure performance in order to improve your models or in order to select the best performing model, because again, there are many different types of models available. Now, within predictive analytics, there are also a lot of tasks, and we will focus today on classification. Now, in classification, we try to predict a binary target variable. In general, we call this a case or a non-case. So we try to discriminate within our customer base or within our database more general between cases and non-cases. And to do so, there are many techniques available. For example, very popular is logistic regression. Also, decision trees is often used in the industry. There are more advanced techniques such as support vector machines, neural networks, and so on. And because of the abundance of techniques which are available, it's important to be able to select the best performing model for a certain problem. What we also see is that there are many business problems in which classification is important. For example, in credit scoring, a bank wants to distinguish between those people who will default in the near future and those who won't default. In churn prediction, a telecom operator or any company in general wants to predict which customer will terminate its contract in the near future. In fraud detection, you want to identify those transactions or those customers where fraud is involved, and so on. So there are many business contexts in which classification is important. And what we also see is that the model selection depends on the business in which you're operating. So it could be that a certain model is optimal, for example, in the context of credit scoring, but would not perform very well in the context of churn prediction. So that's also why model selection is business specific. So basically, why do we need classification performance measures? Because it's important to select those models which are the best in our context. And what does a good performance measure needs to do? Well, it needs to take into account the business context, because it seems that not all models perform equally well in all business contexts. Okay, so let's now very briefly introduce how classification models work. Well, basically, the first thing you need when you want to build a classification model is data. You need a data set which has some independent variables which are describing your customers or your instances, your observations, and which you will use to predict a target variable. And in classification, the target variable, or at least in our case, will be binary. So it's either 0 or 1. It's either churn or not churn, default or not default, and so on. And how you proceed? Well, you first split your data set in two parts, in a training set and in a test set. Now, your training set you will use to build your model. That's the first step. You will feed your data from your training set into a model which will learn the dependencies between the independent variables and your target variable. And in a second stage, you can use the model you've trained to predict what will happen with those instances in the test set. And typically, a model will produce scores. For example, a logistic regression will produce probabilities. So you can rank all the observations in your test set in terms of the probability they are going to be a case. In terms of the probability, there will be a defaulter. In terms of the probability, there will be a customer, a churner, and so on. And once you have this ranking of your customers based on this continuous output score, you will compare this with the actually observed labels, which are binary. And it's this comparison which is the classification performance measurement, and which can be done in different ways. Now, as I explained already on the previous slide, we will start, when we measure classification performance, we will start by ranking our customers in terms of the predicted scores. And then we need to define a cutoff value. So our scores are continuous, we rank the customers, but then we need to say every customer which has a score which is higher than our cutoff value will be classified as a case. If it's smaller than our cutoff value, it will be classified as a non-case. So defining the cutoff value enables you to map from continuous scores to binary predictions. And once we have done this, we can compare the predicted target variable with the observed target variables. And we can then see how good our model performs. And typically you can summarize this information in a confusion matrix. So on the slide here you can see a confusion matrix. And what we see there is that the columns correspond to the predicted labels, whereas the rows correspond to the true labels. So for example, in the upper left cell, you can see that we predicted this case as a case, and it is in effect also a case. So that's what we call a true case. At the left bottom, we see that we predicted it as a case, but it's actually a non-case, so that's a false case. And we can do that for the 4 entries in our confusion matrix. Now, when we use this classification model in a business context, it typically serves to take certain action. So why do companies normally use classification models? They want to reject certain loan applications, but not all loan applications. So they need to divide their customer base, or to divide the whole set of loan applicants into 2 groups, those who you will reject and those who you won't reject. Now, basically this is taking a certain action towards the subpopulation, and we will assume that they always take the action towards the cases. Now, connected to these actions are also costs and benefits. Let's take again the example of credit scoring. If you correctly identify a defaulter and you will reject his loan, that will be a benefit because you avoid a future loss. If you incorrectly identify a non-defaulter as a defaulter, which is a false case, there will be a cost attached to that because you are rejecting a profitable customer because you think he will default, but he wouldn't. And on top of that, also the action itself could come at some cost. So these costs and benefits you want to take into account when you're measuring the performance, when you're assessing how well your classification model would do in your specific business problem. What we also see is that the true cases, so for example, the percentage of true cases depends on the cutoff value. So if you shift your cutoff value to higher or lower values, all these values in the 4 entries of your confusion matrix will change. Okay, so now we have defined our classification performance in terms of true cases, false cases, and so on. We have attached some costs and benefits to that. So now we can basically calculate the classification profit. And the classification profit we measure incrementally to the base scenario, to a certain base scenario, and we need to make a choice there. And the choice we make is that we assume that the base scenario is this case where nothing happens, so where we don't take any action at all. For example, again, in credit scoring, the base scenario would be we accept all loan applications. Now, we will then measure cost and benefits as compared to that base scenario, and this allows us to write down the formula for the classification profit. And what we see here is that our classification profit consists of the percentage of true cases multiplied with its associated benefit, and you subtract the percentage of false cases multiplied with the cost. If we have a closer look to this classification profit, we see that it depends on 4 elements in general. It depends on the class distribution. The class distribution is a property of the business problem you're working with. For example, in customer churn, the class distribution would be the percentage of churners in your population. For example, in churn, this is usually around 3 or 5%. The classification costs or benefits, these are also related to the specific business context, as we explained before. Thirdly, you have the classification output. Now, this is related to the classification model you are using. If you're using different models, you would have different classification output and different performance because of that. And finally, there is the element of the cutoff value. I told before that every entry in the confusion matrix depends on the cutoff value. Well, that's also true for the classification profit, which is derived from the confusion matrix. So if we change the cutoff value t, our classification profit will change. Now, the first 3 of these 4 elements are given in a specific context. You cannot change the class distribution that's given in a certain business context. Also, the costs and benefits are fixed. The classification output you can change by using different models. But the cutoff value t, that's something which can be freely decided by the company. They decide what is our cutoff value and how many of our customers will we target. Once you have ranked your customers, you can shift your cutoff value up or down, thereby influencing the fraction of your customer base you will target with your certain action. Now, if we have this freedom, why not using it? And that's exactly what the maximum profit does. We will maximize the classification profit by choosing the optimal cutoff value. So basically, we will play with the cutoff value t until we achieve the maximum classification profit, which is possible. Now we can use this maximum profit to compare model performance. So we can take, for example, a logistic regression, optimize the cutoff value, we know how profitable it would be, and we compare that with the profitability of a decision tree, of a neural network, and so on. So we will measure our model performance in terms of how profitable is this model if we would apply it in the business context we are now working in. Now, this has clearly some benefits for the business user. First of all, he gets his feedback on the market outcome. He gets a feeling for how profitable it would be to build the model and employ it in a certain campaign. And secondly, he gets guidance about how many people he needs to target. Traditional performance measures, such as, for example, the AUC, would tell you which is the most, or which is the best performing model in terms of that specific criterion, but it doesn't tell you how many customers do you need to target. Well, the maximum profit will do that, and it ensures you that you achieve the highest profit which is possible in the context you're working in. Now, this is all great, but in reality, there are sometimes uncertainties. Uncertainties about the costs and the benefits of your specific business context. Now, in that case, what we could do is we could calculate the maximum profit, but we take into account the uncertainty by assuming a probability distribution for certain costs or certain benefits. And we then calculate the expected maximum profit with respect to these probabilistic cost-benefit parameters. This also has an additional benefit, so basically the expected maximum profit shares the same benefits as the maximum profit, but on top of that it will be more robust with respect to parameter uncertainty. So if there are some parameters a business user is not sure about, he can incorporate this uncertainty into the expected maximum profit measure, and this measure will be more robust to variations in this parameter. So that's interesting for the business cases where there is not always a clear information about certain costs and benefits. Okay, so now we have defined in a theoretical way the maximum profit and the expected maximum profit measure. How can we apply this in a real-life case study? Well, to do that, we need to do a couple of things. First of all, we need to determine the costs and benefits for the specific business context we are working in. Secondly, we need to define the profit equation based on these parameters. And finally, we need to choose a probability distribution for the cost and benefit parameters. And that's exactly what we will do in the following case study. We will illustrate the use of our maximum profit and expected maximum profit measure for customer churn prediction. And actually, we will work on a case study in the mobile telecom industry, which has severe problems with customer churn because churn rates can go up to 40% annually, and they want to optimize their retention campaigns by using classification models. And of course, this is a classification problem with a binary target. Would a customer churn or not in the next period? Okay, so let's start with the base scenario. The base scenario is again the scenario which we will compare, which we will compare to measure our costs and benefits. And the base scenario here is that our telecom operator is not doing anything in order to avoid customer churn. So every period, there are a number of customers which are flowing out of his customer base. And per customer, the telecom operator is losing the customer lifetime value of that customer, which is obviously a bad thing. Now, to do something about that, the telecom operator will build a classification model, and he will rank his entire customer base in terms of riskiness to churn in the next period. He will also define a cutoff value in order to map the continuous scores to binary labels. And then he will approach those customers who are classified as churners with a certain retention offer. Now, to contact the customers, this has, of course, a certain cost, and also the retention offer itself has a certain cost. And what the telecom operator hopes is that part of the would-be churners who he is approaching will change their mind and will be retained, which would yield a benefit because they can retain some part of the customer lifetime value minus the cost of the retention offer. Now, what are the costs and benefits in this business case? Well, first of all, there's the customer lifetime of the customer, because this is the value of your customer which you can retain if he doesn't churn. There's also the cost of the retention offer and the cost of contacting the customer, which is important because giving a retention offer to a customer which is not intending to churn is obviously a cost. And then there's also the acceptance rate, which is very important because you can make a retention offer to a certain customer, but if he doesn't accept your retention offer, you're still losing him and you lose the cost of contacting him. And it's exactly this acceptance rate which is not so certain for many telecom operators. So they can have quite accurate information about the customer lifetime value, the cost of a retention offer, the cost of contacting a customer, but the acceptance rate is quite difficult to estimate. So the expected maximum profit measure allows a telecom operator to incorporate this uncertainty into their performance measurement. And we've demonstrated that with a case study where we have built 22 types of customer churn models for 10 different customer churn data sets. And for each data set, we selected the best performing model in terms of a traditional performance measure, which is the AUC, and in terms of the EMP measure. And we then calculate the profitability of the resulting churn campaign for both situations, and we compare the results. Now, the questions we want to ask is whether there is a difference in profitability between the different model selection procedures. So if we select our model based on AUC, is it more or less profitable as compared when we select our model with the EMP measure? And secondly, what about the optimal fraction? I was telling before that our EMP measure gives some information about how many customers you need to target. Well, what's happening with that? How is that estimated? Well, if we look at the results, they are displayed here in the table. Well, we see basically in the most right column that the difference between the EMP-based method and between the AUC-based method for model selection, there is some difference in terms of profitability. So the EMP-based model is equally or more profitable than the AUC-based model selection, which is a good result because it allows telecom operators to boost their profitability by really choosing the most profitable model. And secondly, what we see is that the optimal fraction, which you see in the blue highlighted column, gives really useful information because it tells the company how many customers do you need to target. For example, for the first data set, that would be around 2%. But there is, for example, a data set where it would be 0%. This is very interesting because it basically tells you that if you would have built a certain model, that particular model, to predict customer churn, and you select the best performing model, by the way, for that particular data set, even the best performing model would not be able to give you any profitable results. So it's better not to do any churn management campaign at all, which is, in my opinion, very useful information, and information which is not given by, for example, the AUC measure. Okay, so to wrap up my presentation about the EMP measure or the expected maximum profit measure, while this measure incorporates costs and benefits specific to customer churn in this case study, but it could be specific to any business context. It takes into account the uncertainty about the acceptance rate, but in more general case, it could take into account uncertainty about any cost-benefit parameter. It helps us to select this model which leads to the highest profit, and it gives information about how many people you need to target in your retention campaign to obtain that maximal profit. And finally, which is very important for managers because it helps them to adopt decision support systems, it provides an estimation of the profit and loss of a retention campaign and gives some feedback of the future market outcome.